Hello everyone. For today's lecture video, we'll be talking about the fourth installment for our lecture series about stoichiometry. We'll be having its part 4A. Now this will be the objectives. The learning objectives are, first is we need to differentiate limiting and excess reagents. Second is calculate amount of limiting reagents and remaining excess reagents from a reaction. Third is to calculate an experiment's reaction yield. For the outline, we have the following. We'll be discussing on how to compute limiting reagents, as well as computing for reaction yield. Again, apologies for the ambient noises that you may be hearing or will be hearing along the way, but nonetheless, let me continue with the content. Let's start with limiting reagents, and as well as reaction yield, of course. Now, limiting reagent is defined as the following. The limiting reagent or reactant is that reactant that is consumed first in a chemical reaction. Let me repeat. Limiting reagent or limiting reactant is simply the reactant that is consumed first in a chemical reaction. Meaning to say, siya po yung unang nauubos or unang nakukonsume kapag nag-undergo po ng chemical reaction ang mga reactants. It's called a limiting reactant because it limits the extent of a chemical reaction. Meaning to say, nililimitahan niya kung hanggang saan kung gaano kadami ang produkto na maibibigay ng isang reaction. The maximum amount of product formed depends on how much limiting reagent was originally present. So say for example, if your limiting reactant was 2 grams, it would predict that the product will not exceed 2 grams. So ibig sabihin, limitado. Hindi pwedeng lumagpas sa 2 grams kasi ang limiting reactant or the value or say for example, your theoretical value for a limiting reactant is 2 grams. So dapat yung mga magiging produkto mo, hindi lalagpas ng 2. Okay? It could be exactly 2 grams but never more than 2 grams. That is the meaning of the third point. The maximum amount of the product formed depends on how much limiting reagent. So hanggang maximum lang. Kung 2 grams, again, ang limiting reactant, say for example, yung maximum na pwedeng maging product mo, okay, maximum amount of product will also be of that of 2 grams of the limiting reactant. Okay? Okay. Now, how about excess reagents? Now, excess reagents are the reactants present in quantities greater than necessary to react with the quantity of the limiting reagent. Now, these reactants are what is left after the limiting reactant is fully consumed. Meaning to say po, pag sinabi excess reagents in Tagalog, ito po yung sobra, ito po yung mga hindi na-consume. Yung second point po, sinasabi nito na ang excess reactants ay yung mga natitira, okay, seemingly mga latak or mga natira after maubos na yung limiting. So kapag naubos na yung limiting reactant at mayroong mga natira, yun ay excess reagents, as the name suggests, excess. Okay? Okay. To further understand, let's have this illustration. Say for example, you have here your patties, pair of buns, and then the cheese and your potatoes here. Not potatoes, okay, but tomatoes rather, tomato, okay? These are your reactants. Now, among the 4 ingredients, alamin natin kung alin ang limiting. Sa mga ingredients na to, it looks like the patty. Patty ang magiging limiting. Bakit? Kasi yung patty ay 3 lang. Yung pagiging 3 bilang niya lang, siya ang magdidikta kung gaano kadami ang maging produkto. Tingnan mo yung mga products natin. 3 product ang na-form. 3 burger or complete burger. Bakit 3 lang? Kasi nga, yung limiting mo ay 3 patty. Yung 3 patty na yan ang nagdikta kung gaano kadami ang magiging maximum na magiging produkto. So ngayon, ang maximum product natin ay 3 burger. Kasi nga 3 ang ating limiting. And then whereas, when you join all of the reactants or seemingly they undergo a chemical reaction, your excess are these. Ito yung mga hindi nagamit. Since 4 itong pares ng tinapay, may isang hindi magagamit. Meron ka naman ditong 1, 2, 3, 4, 5, 6. Meron kong 6 na keso, yung 3 ay hindi nagamit. Then you have your 1, 2, 3, 4, 5, 6, 7. Okay? So, tigda 2 tomato slices ang nilagay. Dahil 7 ito, yung 6 ay magagamit, yung isa ay excess. So, that's the idea between limiting reactants and excess reagents. Limiting would dictate the maximum product, and then the excess are the amount of reactants that is left when the limiting reactants are consumed. Okay? Okay. Now, this is a question. Okay? Determining the limiting reactant. Now, why do we need, or why is there a reason for us to determine a limiting reactant in a chemical reaction? Now, knowing the limiting reagent or the number of a limiting reagent in a chemical reaction is very important because the quantity of this reactant will determine the maximum amount of product that can be obtained from a chemical reaction. So actually, nabanggit ko na siya kanina, ang kahalagahan bakit natin kailangan malaman ang value ng limiting reactant. Kasi pag alam natin kung ano ang value ng limiting reactant, alam din natin ang magiging maximum products. So say for example, the value of our limiting reactant is 10 grams. So ibig sabihin, kapag nag-undergo ng chemical reaction, ang maximum na dami ng product na pwede lang magawa ay 10 grams lang din. Hindi pwedeng lumagpas, maximum na yung 10 grams kasi yun yung dinikta ng limiting. Okay? Kaya siya limiting dahil naglilimita. Now, let me show you a sample problem and the procedure. So this is the problem. So we have here your chemical reaction as well as the molar masses for each substance. So no need to compute for the molar masses because the molar masses for each substances are already provided. And then we have here the question. In an experiment, 3.25 grams of NH3 are allowed to react with 3.50 grams of oxygen gas. So, the reactant side. These are the questions. Which reactant is the limiting reagent? So, between NH3 and O2, alin daw dyan ang limiting? Which reactant is the excess? So, alin daw ang excess sa dalawa? How many grams, or the theoretical yield, of NO are formed? How much of the excess reactant remains in the grams? Or rather, let me repeat, how much of the excess reactant remains in grams after the reaction? So let me explain on how this is done. The first thing that we need to do is start by writing the balanced chemical equation for the reaction. Okay, so first we write the balancing or the balanced chemical reaction. So I hope you learned from the previous lecture videos on how to balance chemical reaction. But in this case, let's assume that this is already the balanced chemical equation. So, lagi po nating i-check, okay, kung balance na po yung binigay na chemical reaction sa problem. In this case, I already have here the balanced chemical reaction. Okay, so we just assume that I've undergone the process of balancing it. So, I now have here the numerical coefficients indicating that this is already balanced. Okay? Second step, convert all given quantities of the reactants into number of moles. So, lahat daw po nung given ay kailangan natin i-convert into mole. So, all given should be converted into mole unit. So, tignan natin yung given. Ang given po natin ay grams. So, grams ay gagawing mole unit. So, how do we convert gram? Okay, so nandito na tayo sa second step. How do we convert gram into mole unit? We will be using the conversion factor molar mass. Okay, molar mass of the substance. So, i-convert po natin yung mga given. We have here 3.25 grams of NH3 and then 3.50 grams of O2. So, kailangan po natin silang i-convert into mole unit as indicated by the second step. So, may mga molar masses na silang provided here. So, pwede natin silang gamitin. So, I put 17.0 grams and then 1 mole at the numerator. Grams will be cancelled. And now, I have the unit mole of NH3 for the particular substance. And then for O2, I have this one, 32.0. So 1 mole all over 32.0 grams. So grams will be cancelled. I now have the unit moles of O2. Okay? Okay. Next. Converting them or input them in your calculator, you shall have this answer. Okay, so I have the same solution. So let me just copy the answer, 0.191 and then 0.109. Okay, so that's step number 2. Converting the given grams into mole unit. Third step. Okay, third step, ang sabi, use the mole ratio from the balance equation to calculate the number of moles of product produced by each reactant. Ano yung sabihin yan? Ibig sabihin lang po nito, itong mga nakuha natin sagot, itong 0.191 mole NH3 at 0.109 mole O2, ay i-convert natin. So, ito po, mole NH3 or mole O2, i-convert po natin via molar ratio into mole unit for each reactant. So tignan po natin yung tanong, balikan natin. Ang tanong sa letter C, how many grams of NO? So para mo pong padali at diretso na yung pag-solve natin, itong mole NH3 at mole O2 ay idadaan natin sa molar ratio or i-convert natin sila into mole NO. Okay? Bakit hindi mole H2O? Pwede naman natin i-convert si mole NH3 at mole O2 into mole H2O. Okay lang naman yun. Kaso, hindi naman hinihingi ng tanong. Ang hinihingi ng tanong ay theoretical yield ni NO. So, mas bagay at mas wise na i-convert na natin si mole NH3, okay, si mole NH3 at si mole O2 into mole NO. Kasi yun yung tinitanong ng letter C. Pwede rin naman, again, H2O, kaso sayang oras, hindi siya wise, hindi hinihingi ng tanong. I-directly convert na natin itong mole NH3 at mole O2 into mole NO using molar ratio. Okay? Okay. So that is third step. So let me just solve for that one or write the solution for everyone to see. So kuhain ko lang itong binigay na sagot, 0.191 mole of NH3 and then 0.109 mole of O2. Again, i-convert ko daw sila into mole NO. So ang ilalagay ko dito ay mole NO sa taas for both of them. And then the denominator itself, mole NH3. And then mole O2. So, mole ratio ang gagamitin. So, saan tayo titingin? Dito po sa balanced chemical equation, sa mga numerical coefficient. So, ang NH3 natin ay 4. So, I'll be writing 4 at the denominator. And therefore, and NO naman po, 4 din. Okay? So, how about O2? Ang O2 po ay, sorry about that. Ang O2 ay ito. 5 ang kanya numerical coefficient. So, I'll be writing 5 here. And then for NO, that's 4, so I'll be writing 4 here at the numerator. So canceling units, I will now have mole of nitrogen monoxide, okay, as the one being required. So input this one in the calculator, I have this following answer. So 0.191 and then 0.08, sorry about that, let me rewrite, 0.0872 moles of Na2. Okay? Now, at this point, we may stop or take a pause kasi pwede na po natin sagutan yung mga tanong. Okay? Sa letter A and letter B, tinatanong tayo ng letter A, alin ang limiting reactant? At letter B, tinatanong tayo kung ano yung excess reactant. So at this point, with third step, we can actually answer A and B. O2 produce less product. Ito daw po, itong si O2 ay nag-produce ng mas mababang mole value. Ito, 0.0872. Dahil mas mababa ang na-produce ni O2, si O2 ang ating limiting reactant. And then, okay, at dahil si NH3 ay mas mataas ang kanyang nabuo or naging answer, 0.191, our NH3 will be our excess reactant. So at this point, letter A and B determining the limiting reactant and excess reactant are now answered. Let me repeat how it was determined. Tignan po itong sagot step number 3. Alin ang mas mababang mole unit for NO? Mas mababa ang 0.0872. Tignan kung ano ang ginamit. Ang ginamit dyan ay O2 na substance. So therefore, the limiting reactant or reagent will be O2. Whereas yung mas mataas na mole unit for NO, 0.191, siya naman ang magiging excess. And that is your NH3. Okay? Okay. So ngayon, meron pa tayong letter C and D na sasagutan. So continue pa tayo. For letter C, we proceed with step number 4. Step number 4, how many grams of NO are formed? Now, how do we answer that? How many grams of NO are formed ay magbabase ka or gagamitin mo ang pinakamababa na value ng mole NO para masagutan tong number 4 or yung letter C. Ito po. So using the value of the mole unit from the computed limiting reagent, okay, that is 0.0872 mole unit of NO, siya po yung gagamitin natin So we will be converting mole NO into grams NO. Using what? Using the molar mass of nitrogen monoxide. So we'll be putting here 1 mole of NO and then grams of NO. So dahil ang molar mass ni nitrogen monoxide ay binigay na ng problem, so don't worry. So we can actually write it here. So mole of NO is already provided. This one, that is 30.0. So I'll be writing here 30.0. So mole NO is now cancelled. I now have grams of NO, which is the one that I'm required to solve for. So click natin, step 4. So I have the same solution, and then the answer is 2.62. 2.62. Okay, sorry about that. That is 2.62 grams of NO. Right? So that will be your answer for letter C. Okay? Okay. Now, out of A, B, C, and D, meron ka ng sagot for A, B, and C. Letter D na lang. How much of the excess reactant remains in the grams after reaction? So, si letter D ay masasagutan using step number 5. Okay, so step number 5 na tayo. Proceed ako. Step number 5, ito po ang gagawin. Alright, for step 5, ito po yun. The amount of NH3 in excess can be calculated by determining the amount of NH3 that reacted to produce 0.0872 moles of NO. The amount of excess reactant left over is the difference between the initial amount and the amount reacted. Let me explain the procedure in a much more easier sense. So, ang gusto na po gawin for number 5 para masagutan sa step letter D ay ganito. Ang gagawin daw natin ay si mole NO. Mole NO, yun po yung nasolve natin kanina na pinakamababa, that is 0.0872 moles of NO. Ay i-convert natin into moles of NH3 and then grams of NH3. Yun lang po yung gusto sabihin ng step na ito. Then after getting grams NH3, isusubtract po natin siya with its initial amount. So let me show you how. So again, mole NO, ano pong value ang gagamitin? Ang gagamitin nating value as a given ay ito pong pinakamababa na mole unit, yung galing sa limiting reactant O2, 0.0872 moles of NO. So I'll be writing 0.0872 moles of NO. And then using molar ratio, I can convert moles of NO into moles of NH3. So again, titingin tayo sa balanced chemical equation for numerical coefficient of NO and NH3. So for NO, we have here 4. For NH3, we also have 4. So 4 all over 4. So I'll be writing here 4 all over 4. So mole will be cancelled, or mole NO will be cancelled. We have moles of NH3. So nandito tayo sa part na to. Next is converting mole NH3 into grams NH3. That is using the molar mass of the substance NH3. So good thing, provided na ang molar mass NH3 from the given. Here, 17.0. So I can now write the molar mass of NH3. So 1 mole of NH3 here, and then 17.0 grams of NH3. So moles of NH3 will be cancelled. The remaining unit now is grams of NH3. Okay? So input that one in the calculator. So let me just check. So we have the same solution. 4 all over 4 multiplied by 17.04 all over 1. We have 1.49. Okay? Now, 1.49 grams of NH3 is not yet the answer. Bakit? Kasi ito po yung last sentence. The amount of excess reactant left will be the difference between initial and amount reacted. Ito po yung amount reacted. Itong 1.49. Kailangan pa natin makuha muna yung initial amount. Yung initial amount is yung given. Ano po yung given? Yung given, according to problem, is that our NH3 is 3.25 grams of NH3. So, ang simpleng gagawin lang po natin ay, sa 3.25 ay isusubtract natin with 1.49. So 3.25 minus 1.49 grams of NH3. Our answer is 1.76 grams of NH3, and this will be your answer for letter D. Let me repeat. Ito pong 1.49 grams of NH3, amount reacted pa lang po yan. So ito, yung nakalagay sa PowerPoint, 1.49. Hindi pa yung final answer. Kasi need pa nating isubtract si 1.49 sa initial or sa given amount. Ang given amount ni NH3 according sa word problem ay 3.25. That is why, itong 3.25 na galing sa word problem, binanggit yan sa word problem, babawasan natin ng 1.49, getting 1.76 as the final answer. Therefore, 1.76 grams of NH3 is our answer for letter D. Okay? Okay. Now, I hope you learned a thing or two on how we can compute limiting reagents, excess reagents in this particular lecture video, and also the procedure on how to do it. Now, I hope you will tune in further because on the next lecture video, I'll be explaining how to compute for the reaction yield. Okay? Thank you, and I hope you'll have a great day.